We have launched 4 satellites for AsiaSat over the years, and this will be our 5th satellite for AsiaSat with AsiaSat 9. ILS is proud to partner with AsiaSat in helping them launch their newest generation of satellite, which will enable them to develop their new business opportunity in the Asia-Pacific region.
Live from Pad 39 from the Baikonur Cosmodrome in Kazakhstan, you are watching coverage of the launch of AsiaSat 9 aboard an ILS Proton.
The weather looks favorable in Baikonur. The most recent weather readings I've received show that current conditions are partly cloudy skies with about 10 kilometers of visibility, a liftoff temperature of 7.7 degrees Celsius, which is about 46 degrees Fahrenheit, ground winds out of the northwest at 3 meters per second, which is well below our limit, and upper level winds are within limits at all altitudes. So weather is well within constraints, and currently we are go for launch on the AsiaSat 9 mission.
Stay with us. The countdown to the launch of AsiaSat 9 begins now. Hello and welcome to today's ILS coverage of the launch of AsiaSat 9. I'm Jennifer Gladstone, your host for today's launch. We're about 20 minutes to lift off. It's great to have John Palmay as my co-host today. John has launched more than 60 spacecraft and is the COO and Vice President of Programs and Operations for ILS. John, it's great to see you.
Thanks.
So how about a quick update on the pre-launch activities going on in Baikonur right now?
Sure, Jennifer. As you may know, at this point, mission teams are in their places in the launch bunker, in the control rooms, ground stations, and communication centers around the world. Now, as AsiaSat 9 awaits liftoff aboard the ILS Proton from Launch Pad 39 in Launch Complex 200 at the Baikonur Cosmodrome, we are all thinking about the impressive amount of time and effort by ILS and our partners at AsiaSat, SSL, and Khrunichev. You know, from conception to design, manufacture to launch, and finally into commercial service, this is a large-scale operation involving precision planning and detailed execution by the entire team. Liftoff is scheduled for September 29th at approximately 2:52 a.m. at AsiaSat in Hong Kong, at 12:52 a.m. at the Baikonur Cosmodrome, which is actually September 28th here at the ILS Broadcast Center at 2:52 p.m., 11:52 a.m. at SSL in Palo Alto, California. AsiaSat 9 will be the 3rd ILS Proton launch of 2017 and the 96th ILS Proton launch overall. This is actually the 5th AsiaSat satellite launched on an ILS Proton and the 31st SSL satellite to be launched on an ILS Proton.
Thanks, John. Now let's take a look at the mission flight profile for AsiaSat 9.
This is the Geosynchronous Transfer Orbit, or GTO mission flight profile for AsiaSat 9. The Proton M launch vehicle will utilize a 5-burn Breeze-M mission design and lift off from Pad 39 at the Baikonur Cosmodrome in Kazakhstan with the AsiaSat 9 satellite on board. The 191-foot, or 58.2-meter tall ILS Proton is a 3-stage rocket with a restartable upper stage. The Proton's first 3 stages propel the orbital unit, consisting of the Breeze-M payload adapter system and the AsiaSat 9 satellite, into a suborbital trajectory during the first 10 minutes following launch. After that, the Breeze-M takes the spacecraft through the parking, intermediate, transfer, and geotransfer orbits during the remaining 9 hours of the mission. The liftoff phase begins with the ignition of the 6 powerful first-stage engines that generate 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its pitch axis with the flight launch azimuth of 61.3 degrees as it travels in an east-northeast direction across Kazakhstan towards the Pacific Ocean. The first stage engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Soon after that, the first stage separates from the second stage. As the second stage ignites, 540,000 pounds of thrust is generated for 3.5 minutes, and then stage 2 separates, allowing the third stage engine to fire and generate 131,000 pounds of thrust for 4 minutes. Soon after third stage ignition, the payload fairing, consisting of two symmetrical payload fairing halves, separates and is jettisoned from the launch vehicle. Having traveled from Baikonur to eastern Russia at 51.5 degrees north latitude, Stage 3 separates from the orbital unit, which is now moving at about 7,300 meters per second or 4.5 miles per second relative velocity in a suborbital trajectory. At this point in the mission, the BRIES-M upper stage, designed to inject payloads into a variety of orbits, takes over. The first of 5 BRIES-M burns occurs about 1.5 minutes after the third stage separation. The purpose of this first BRIES-M burn is to achieve a low Earth circular parking orbit of 168 kilometers perigee and 179 kilometers apogee. The first burn spans from Siberia to Russia's east coast. 52 minutes after the main engine cutoff of the first burn, or MECO-1, the second BRIES-M burn occurs, placing the spacecraft into an elliptical orbit called the intermediate orbit. Perigee is increased to 270 kilometers and apogee to 5,000 kilometers, and inclination slightly reduced to 50.4 degrees. This nearly 18-minute burn spans from the South Atlantic 800 miles east of Rio de Janeiro to Libya. In a 19.9-minute sequence, the third BRIES-M burn is executed, the auxiliary propellant tank, or APT, is jettisoned, and the fourth BRIES-M burn is completed, resulting in the transfer orbit, a more elliptical orbit. In the transfer orbit, the apogee is greatly increased to 35,805 kilometers, more closely matching geosynchronous altitude, while perigee is slightly increased to 434 kilometers and inclination reduced to 49.2 degrees. The third and fourth BRIES-M burns take the spacecraft from the South Pacific 200 miles west of Chile to 300 miles west of Morocco. The BRIES-M performs various attitude maneuvers during the coast phases between burns, allowing AsiaSat 9 and the BRIES-M to be exposed to the warming rays of the sun at pre-programmed solar illumination angles designed to meet power and thermal requirements. About 13.5 minutes after MECO-5, AsiaSat 9 is separated from the BRIES-M, having reached its targeted GTO orbit near the east coast of Africa. The total mission duration is 9 hours and 13 minutes in length.
Stay up to date on the status of AsiaSat 9 mission. Visit the ILS website, ilslaunch.com, to follow the progress of the launch. Follow us on Facebook and follow us and join the conversation on Twitter. Now, John, you had a special tribute you wanted to make to a dear colleague and a friend.
Yes, Jennifer, thank you. As a program director, I had the honor of meeting and working extensively with Dr. Yahe Chu on AsiaSat 5 and 7. And sadly, Dr. Chu passed away late last year. Dr. Chu joined AsiaSat in 1989 as employee number 4. During his tenure of service, Dr. Chu made sterling contributions to the company's expansion. He played a fundamental role in all technical matters involving the launches of AsiaSat 1, 2, 3S, 4, 5, and 7, and in maintaining and operating the satellite fleet and interfacing with the customer's operations and technical needs. Dr. Chu received his BS degree from National Taiwan University and a master's and PhD degrees from Yale University, all in physics. On a personal level, he was a gentleman and a friend to many, including myself, and was both respected and loved by those who are lucky enough to know him. His wit, his generosity, and his warm smile and laugh are really missed by us all. But his legacy lives on in those that knew him and the many satellites that continue to orbit the Earth as a result of his drive and passion. In English, it's to the stars, and in Latin, ad astra, Dr. Chu, and thank you for your wisdom and your friendship.
We are now a little over 13 minutes to the launch of the AsiaSat 9 satellite aboard an ILS Proton. The mission is currently a go for launch at Pad 39 and Launch Complex 200. The launch location for all Proton missions is the historic Baikonur Cosmodrome, which is the site where the first satellite, Sputnik 1, took the first orbital spaceflight on October 4th, 1957. As we come up on this 60th anniversary, let's take a closer look at the launch facility.
The Baikonur Cosmodrome is the world's first and largest operational space launch facility and has been in operation since 1955. It is located in the Kazakhstan desert, approximately 2,100 kilometers or 1,300 miles southeast of Moscow. The Cosmodrome is large and extends about 100 miles from east to west and 55 miles north to south. which is about the size of Holland. The Baikonur Cosmodrome is under a long-term lease from the Republic of Kazakhstan. Under Roscosmos, the Russian Federal Space Agency, Baikonur remains a busy spaceport with numerous commercial, military, and scientific missions being launched. The Cosmodrome is where the crew of astronauts are launched aboard Soyuz to the International Space Station. Today's Proton launch will be from Pad 39 in Area 200, one of the 2 launch pads available for Proton launch use.
As we move closer to the launch, we'd like to hear from our partners. And now a joint VIP greeting shot earlier at the Baikonur Cosmodrome from Andrew Jordan, AsiaSat's president, CEO Kirk Peischer, president of ILS, and Tim Cole, SSL program manager.
Hi, I'm Andrew Jordan. I'm delighted to be here today to represent AsiaSat for the launch of AsiaSat 9. AsiaSat 9 will be our most powerful satellite ordered to date, and we're very excited about it because it will open up new markets with dedicated high-powered Ku band beams for Myanmar, Indonesia and Mongolia, and a C-band beam which is double the power of the satellite AsiaSat 9 will replace AsiaSat 4. This will significantly reduce the cost per bit to our customers and will open up new markets in areas such as video applications, data and mobility services for maritime and aviation broadband. I'd like to take this opportunity to thank our partners at SSL and ILS, with whom we have a long and proud relationship, including 5 satellites ordered and 5 launches. I'd also like to thank the technical excellence of Khrunichev State Production and Research Center, and I would like to thank the dedication and professionalism of the mission teams who've made this launch possible. Thank you.
I'd like to pay special attention today to thank the teams from Space Systems The RAL, ILS, and Khrunichev for their hard work in getting us to this point today. And a special thanks to AsiaSat for putting their trust in us and launching the AsiaSat 9 spacecraft.
Success in this industry comes from building strong relationships. Nothing speaks more to that than launching our 5th satellite for AsiaSat on our 31st ILS Khrunichev-provided Proton. I would like to thank Roger Tong, Iman Kamel, and the incredibly hardworking engineers at AsiaSat. Together, we've overcome a lot of obstacles. While Jeff Block and his team get the satellite ready for launch, I'd like to thank Jessica Phillips, Martin Ron, Steve Rosenau, and the team of engineers and technicians back in Palo Alto to make this day possible. Go Proton, go BreezeM, go AsiaSat 9.
And we are just a little bit over 9 minutes before launch. With today's impending launch, ILS had 2 campaigns being conducted simultaneously, with Amazonas 5 launched September 12th and AsiaSat 9 today, following a successful federal Proton launch on August 17th. In this short video, ILS President Kirk Peischer tells us about ILS challenges and innovations surrounding managing multiple launch campaigns.
Khrunichev has been around launching Proton for over 50 years, and we know how to launch rockets. We have the processes and the procedures in place which allow us to achieve a significant launch cadence. Our processes, our procedures, our manifesting all allows us to do that and maintain a high launch rate. And as far as production goes, Khrunichev is also able to produce flight hardware to support 12 launches a year. It's difficult, but it's not unprecedented for a professional like Khrunichev to be able to go execute. On top of that, we have the facilities that allow us to do that. We have 2 spacecraft processing centers at Baikonur, as well as 2 launch pads, Pad 24 and the recently upgraded Pad 39. So we have the facilities, we have the tools, the experience to be able to go execute it. AsiaSat and ILS have a strong history of working together to achieve the business successes that have enabled AsiaSat to be a premier player in the Asia-Pacific marketplace. Working with Space Systems The RAL and the AsiaSat team, the Khrunichev folks as well as the ILS team, they're all doing a fantastic job, and it's all worth that sacrifice that we make. And I'd like to thank each of those individuals personally for their dedication and support. It's a lot of hard work. Launching rockets is sometimes challenging from a personal perspective, but it's so rewarding once you see that launch go off and the spacecraft is separated and we've enabled a new opportunity for our customer.
A lot of time, effort, and resources go into the manufacturing and launch of a commercial satellite. Let's take a chronological look at the AsiaSat 9 journey to launch.
The journey from concept to launch takes about 2 years for a commercial satellite, beginning with the satellite operator and the manufacturer's designs, then progressing to integration and launch. Each launch campaign begins with the arrivals of the spacecraft and the crew in Baikonur. The satellite arrives via the massive Antonov cargo jet at Kryny Airfield in Baikonur and is carefully offloaded to a special road transporter from the Antonov's cargo bay. The spacecraft makes a 6-hour rail trip from Kryny Airfield to the launch processing facility in Baikonur in a thermally controlled environment. Systems tests and other operations to include fueling of the spacecraft are performed by the crew in the high bay. At this point, joint operations begin. The skilled, experienced teams work side by side to bring all the flight hardware together. In Hall 101 at the Baikonur Cosmodrome, the satellite is mated to the BreezeM restartable upper stage. It is then rotated horizontally to be encapsulated in the payload fairing. Joint testing accompanies every mating activity to verify proper functioning of the many components. From this point forward, the spacecraft, fairing, and upper stage are referred to as the ascent unit. The booster stages are mated to form the entire assembly of the Proton Integrated Launch Vehicle in Hall 111. The integrated launch vehicle is then fueled at the BreezeM fueling station. After BreezeM fueling, the rocket rolls to the launch pad. Slowly and carefully, the hydraulic erectors move the rocket from a horizontal to a vertical position to be placed in the mobile service tower. The mobile service tower moves in to provide services and accessibility to the launch vehicle and spacecraft. As a tribute to Yuri Gagarin, the first man in space, Proton is rolled out to the launch pad at precisely 6:30 a.m.
And you can see the launch pad right now. We are just barely over 5 minutes to launch. Please stay with us as we count down to the launch of AsiaSat 9 aboard an ILS Proton. Asia Satellite Telecommunications Company Limited, known widely as AsiaSat, has been Asia's premier satellite operator since it was established in 1988. Let's learn more about AsiaSat 9, the largest satellite AsiaSat has ever launched, and its satellite fleet now in video prepared by AsiaSat. And now John will take us through to the launch of AsiaSat 9 aboard an ILS Proton. John?
Longtime ILS mission director Russ Pretula is in the underground launch bunker near Pad 39, and in my earpiece, giving me live updates from Baikonur is Judy Opp, ILS program integrator. Hi, Judy.
Hi, John. How are you?
Good. All reports are that systems are go for launch. For our viewers, can you tell us where the various teams are right now?
Sure. The critical personnel for both SSL and the customer are in the control room here in the building 92850, and they're monitoring the health of the satellite. Russ Prytula, the ILS program director, is in the bunker with the Kurnichev team. I'm in the communication room at 92850 and will be providing real-time updates to you and the customer on the status of the mission. All of the non-critical team members have been cleared of the launch pad into a safety zone and are now waiting to view the launch. And my mom is watching from her computer in Arizona.
Hi, Judy's mom. So we have, we're about a minute and change from launch. Hey, Judy, just one question. What number launch campaign is this for you?
I'm getting up to almost 20. I'm 19.
Thanks, Judy. Stay safe and good luck to us all. Before we get into the final moments before launch, let's take another quick look at the weather in Baikonur. Mostly clear at this point with some upper level winds, but all within constraints. And we're currently very much go for launch. We're about 45 seconds from launch. Rocket's quite impressive, the view on the launch pad. All the 4 stages together with the payload fairing is 58.2 meters or 191 feet tall. The launch vehicle has a dry mass of 48,000 kilograms and 698,000 kilograms wet. About 20 seconds from launch. Coming up on T-minus 15, and we're going to step aside and listen to the final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
We have ignition and liftoff of the ILS Proton launch vehicle with the AsiaSat 9 satellite on board. About 10 seconds after liftoff, the launch vehicle performs a roll maneuver to align the launch vehicle pitch axis with the planned northeasterly launch azimuth. Plus 30 seconds. Going through a cloud there. Now the vehicle will soon experience maximum dynamic pressure, or max Q, which is when the aerodynamic force on the vehicle has peaked. For Proton, the max Q occurs at 62 seconds after liftoff at a velocity of Mach 1.6. Visible condensation that appears to be a stream of smoke can sometimes be observed if conditions are favorable. Unfortunately, disappearing into the cloud, we don't have a live video, but we're getting the mission simulation shown. Everything seems to be proceeding nominally as the vehicle ascends over the Cosmodrome in a northeasterly direction into a suborbital trajectory along the route, which provides a parking orbit inclination of 51.6 degrees. We're seeing a telemetry page there of the actual flight telemetry being plotted against the nominal route. About 90 seconds into launch. Now we're coming up on the first stage separation from the second stage. That's set to occur at 2 minutes into the flight. In order to maintain a constant level acceleration, the second stage engines ignite prior to separation from the first stage. On a clear day, unlike today, launch site observers may be able to see a halo effect as the second stage engines ignite. Still awaiting confirmation from Baikonur, but at this time we should have a second ignition of the second stage and a separation from the first stage. Still watching the plot of the telemetry from the vehicle being plotted against the nominal trajectory. And we have confirmation of ignition of the second stage and confirmation of good separation from the first stage. We also have confirmation of the planned level of thrust on all 4 of the second stage engines And the second stage is going to operate for about 3 minutes and 26 seconds. The next key mission milestone will be the separation of the third stage from the second stage at L plus 5 minutes and 27 seconds. About 20 seconds into the third stage operation, the density of the atmosphere at that altitude is lower, so then the payload fairing can be jettisoned. As the mission proceeds, the launch vehicle travels from Kazakhstan into Russian territory, and then our viewers may notice some brief planned delays in our reporting of key mission milestones because the telemetry has to be relayed through multiple ground stations and facilities.
John, thank you so much. The first burn of the Breeze M upper stage is scheduled for completion about 16 minutes into the flight. Our live coverage will conclude shortly afterwards with mission updates posted to the ILS website, Facebook, and Twitter pages thereafter. Now, located in the heart of Silicon Valley, SSL is a world-leading provider of innovative satellites and spacecraft systems. SSL satellites connect billions of people around the world, providing essential communication services such as internet connectivity, ultra HD television delivered directly to homes, and mobile communications for ships and planes. Here's a little more about SSL and the performance, power, and reliability of the AsiaSat 9 satellite. So, John, obviously, we just watched a launch take place at night, but we've done some together that have happened during the daytime.
Sure.
So what determines the difference, day or night?
The time of launch is actually driven by several factors that affect the design of the final flight profile. First, the mass of the payload dictates if we can perform a GTO insertion, such as today, or for lighter spacecraft into a direct insertion into geosynchronous orbit, or GSO. This affects the number of Breeze M burns required and the length of the burns and the mission timeline. In addition, for GTO missions, the spacecraft manufacturer usually has a requirement for what's known as local solar time at perigee, or LSTP. Now, that's just a fancy way of saying that at the lowest point in the elliptical GTO orbit, they have a certain constraint on the angle of the orbit to the Sun. And as we all know, the Earth-Sun angle changes throughout the year, so this leads to a daily LSTP window that varies slightly from day to day. Once we know the spacecraft mass, the mission type, and the LSTP window requirements by the satellite, the Khrushchev specialist can essentially backpropagate a mission design, leading to a required liftoff time to meet all mission requirements. In our case, it's a launch in the wee hours of the morning for the AsiaSat 9 team in Baikonur. Good for us in Washington, D.C. today, not so convenient for our AsiaSat customer in Hong Kong, where it's currently around 3 a.m. And since our last update, I did get confirmation that we have had stage 2-3 separation and stage 3 is burning. At this point, the payload fairing jettison should have occurred as well. And that occurs at a velocity of about 4,600 meters per second, or 2.9 miles per second, at an altitude of 138 kilometers. And that was just confirmed to me over my IFB as well. So our next major milestone happens in a few minutes. That'll be the separation of the Proton's third stage from the Breeze N upper stage.
Right, thanks, John. We've talked about it a little today, and we've given some of our viewers a baseline knowledge of the ILS Proton. Now let's take a more in-depth look at the mainstay Proton launch vehicle.
The total height of an ILS Proton is between 184 and 191 feet, around the same height as a 19-story building. Its gross liftoff weight can be around 705,000 kilograms, or 1.554 million pounds, depending on payload and fuel weights. Proton's initial launch was on July 16, 1965, carrying the Proton 1 spacecraft. If we begin our in-depth look at the Proton in a manner chronologically consistent with the launch phases, we see that the first stage consists of a central oxidizer tank surrounded by 6 outboard fuel tanks. Each fuel tank also carries one of the 6 RD-276 engines that provide first stage power. Total first stage vacuum-rated level thrust is 11 meganewtons, or 2.5 million pounds of force. The second stage is a conventional cylindrical design and is powered by 3 RD-210 engines plus 1 RD-211 engine. It develops a vacuum thrust of 2.4 meganewtons, or 540,000 pounds of force. The third stage is powered by 1 RD-213 engine and develops thrust of 583 kilonewtons, or 131,000 pounds of force. It has a 4-nozzle vernier engine that produces thrust of 31 kilonewtons, or 7,000 pounds of force. Guidance, navigation, and control of the Proton M during operation of the first 3 stages is carried out by a triple redundant, closed-loop digital avionics system mounted in the Proton's third stage. The Breeze M upper stage is powered by 1 pump-fed, gimbaled main engine that develops thrust of 20 kilonewtons, or 4,500 pounds of force. It is composed of a central core and an auxiliary propellant tank, which is jettisoned in flight following depletion. The Breeze M control system includes an onboard computer, a 3-axis gyro-stabilized platform, and a navigation system. Finally, the payload fairing. It consists of 2 symmetrical payload fairing halves and a static envelope diameter of 3.87 meters. There are multiple payload fairing designs presently qualified for flight, including standard commercial payload fairings developed specifically to meet the needs of ILS customers. The payload fairing for commercial launches aboard an ILS Proton separates at the nose cone in a planned maneuver, leaving the Breeze M and the spacecraft, together known as the orbital unit, to continue the journey to its planned orbit. And that is an at-a-glance look at Proton and its stages.
Well, since our last update, I did get confirmation that the Stage 3 operation has completed successfully and that we do have a separation of the orbital unit, which is the Breeze M and the spacecraft, from the third stage. So now we're just waiting on the next mission milestone, which is the first ignition of the first 5 burns of the Breeze M upper stage.
All right, John, thank you so much. The Breeze M upper stage is designed for injecting payloads into low, medium, or geosynchronous orbits. The main engine can be restarted up to 8 times during flight and allows precision injection of the spacecraft into the target orbit. Now let's learn more about Proton's technology and its role in the AsiaSat 9 mission.
Soon, we will have Stage 3 separation from the Breeze M. The orbital unit, or the spacecraft together with the adapter, separation system, and Breeze M, will be traveling at approximately 7,300 meters per second at the moment of separation, or more than 16,000 miles per hour. The Breeze M will ignite for its first burn about 1.5 minutes later and will last about 4.5 minutes. About 4 minutes after the first main engine cutoff, or MECO 1, the vehicle is scheduled to go out of range of our ground tracking stations. After about 70 minutes, we will reacquire the signal prior to the second burn of the Breeze M.
Around this time last fall, ILS announced the introduction of the Proton variants, the 2-stage vehicles to serve the mid-range mass properties of the communication satellites. We have our first customer under contract for Proton Medium, and the development plan is moving along. ILS President Kirk Peischer now tells us more about this new launch capability and some additional competitive ILS product offerings as well.
Proton has had the capability to launch dual satellites for years. In fact, the federal government has been using Proton's capability to launch dual spacecraft regularly. So one of the first commercial dual launches occurred in 2011, where the SES-3 satellite was paired with the COSAC-2 federal program, and that was a commercial federal dual launch. The first full commercial dual launch will actually occur in the fourth quarter of 2018 with the Eutelsat 5 West B satellite paired with the orbital ATK MEV-1 satellite. The 5-meter fairing is a strategic benefit for the Proton vehicle, and it will allow us to really address the full market potential from the big high-throughput satellites that want large antennas and reflectors on it, to dual launch capability, to the LEO constellations, and being able to optimize the number of satellites launched for those constellations. So the 5-meter fairing really opens up a whole new competitive prospectus for us, and will actually benefit ILS and will benefit our customers by providing them a very cost-effective and reliable solution for achieving their mission objectives. The 5-meter fairing will be available on both our Proton M BreezeM and our Proton Medium vehicle.
Since the last time we talked, I did get an update that the first main engine start of the BreezeM upper stage has occurred, and that will be a 4-minute and 30-second burn, and so it's currently going on right now. The mission is proceeding as planned. The Proton launch vehicle has completed the ascent mission, and now the BreezeM will begin the journey to deliver the AsiaSat 9 satellite to the planned separation point at an apogee at the geostationary orbit altitude.
The AsiaSat 9 mission team is represented in this combined greeting from Baikonur by ILS Program Director Russ Prytula, Khrunichev Program Director Mikhail Yakimchikov, and SSL Launch Vehicle Mission Manager Larry Witham.
Hello once again from the Baikonur Cosmodrome. The AsiaSat 9 launch campaign has progressed very well, which is a credit to the experience and cooperation of all the teams involved. Of course, the ideal weather conditions here in September were much appreciated, making our stay in Baikonur pleasant and allowing for several excellent barbecues.
I would like to thank our customer, AsiaSat Company, for many years of cooperation with Khrunichev Space Center and for its continued trust in Proton M BreezeM launch vehicle. We at Khrunichev appreciate such trust and value greatly our friendship.
I'd like to take this opportunity to thank our launch partners, ILS and Khrunichev, but especially AsiaSat, our customer, for their continued confidence in SSL.
I would also like to express my gratitude to the specialists from Loral, ILS and RUAG. Your hard work will lead to the creation of a new man-made star in the sky, AsiaSat 9.
Today is bittersweet because today we're losing 2 members of our team to retirement, and I'd like to take a moment to thank them. Our head of security, Keith Patterson, who's been here for 27 campaigns on Proton. I'd like to thank Keith for his professionalism and being an all-around great guy. And my colleague and fellow mission manager, Jeremy Agolf. Jeremy and Keith, we'll miss you very much. Thank you.
I would like to pay my respects to the man who is considered to be one of the founding fathers of our friendship, Dr. Ya Chu. I would like to express my sympathies to his family. As for our cooperation, I believe that it will live on.
This is the 5th AsiaSat satellite launched on Proton, and we are very happy that AsiaSat keeps coming back. So a big thank you to our longtime AsiaSat customer, SSL, Khrunichev, and all the teams that have worked so hard to get to this point. It has been a pleasure and an honor. As always, go Proton, go BreezeM, go AsiaSat 9.
So Don, one of the questions that we get a lot at ILS is what happens after Proton completes its mission with respect to the satellite? Can you elaborate a little for us?
After spacecraft separation, AsiaSat and SSL will take over operation of the satellite. The spacecraft will execute a series of planned operations which include solar array deployment, reflector deployment, and a series of apogee engine firings. Now this series of engine firings of the satellite will bring the orbit inclination down to 0 degrees and raise its perigee to match the apogee, resulting in a circular geostationary orbit over the equator. Following a period of in-orbit testing, the spacecraft will be positioned and placed into commercial service at the orbital slot of 122 degrees east longitude. There, it's going to begin to provide additional capacity, enhanced performance, higher efficiency, and greater flexibility for direct-to-home video distribution, VSAT broadband, and mobility services to AsiaSat customers.
All right, so John, what is the current status of the AsiaSat 9 mission?
Well, we're now at the point in the mission where the BreezeM upper stage has completed its first burn, and I've had confirmation of that from Baikonur. 4 more BreezeM burns for a total of 5 are required before spacecraft separation. So currently, all the telemetry reports confirm the mission is proceeding as planned and moving along the planned flight path. So far, so good. Well,
this is where our live coverage of the launch of the AsiaSat 9 satellite concludes. Please continue to follow the progress of the AsiaSat 9 launch on our website, ilslaunch.com, and go to the ILS Facebook and Twitter pages for regular mission updates. I'd like to thank John Pelme for co-hosting today's launch with me again today, and from Baikonur, ILS Program Director Russ Prytula and Mission Integrator Judy Opp for mission updates from the Cosmodrome.
I'd also like to recognize the rest of the ILS team in Baikonur. That includes Mission Manager Mike DeSalvo, Campaign Security Manager Mylan Wiley, and Director of Launch Operations Kevin Sloan. Safe travels home to all of you.
So to all of the teams working on the AsiaSat 9 mission and our partners and customers around the world, we thank you for watching along with us.
This is David, voice of